Hi everyone, it's Mrs. Bebo. In this video, we're going to take a look at solving one-step multiplication and division inequalities, this time involving negative coefficients. So there is a trick that we need to worry about whenever we have a negative number that our variable is either being multiplied or divided by. So let's go ahead and get started. So the learning target, essentially, how do I solve and graph these one-step multiplication and division inequalities that have negative coefficients? As a reminder, I've said this in pretty much every video since lesson 7.1, make sure you know your vocab. So here's another opportunity for you to make sure you understand what each of our symbols are, what the meanings are, and again, those word phrases that match. That is going to make life so much easier for you if you have these memorized or at least written down to where you can refer back to them easily. So on this next slide, there's going to be a lot of words. And feel free to pause the video, read through this, but this is essentially the outline for the division and multiplication properties of inequalities when we divide or multiply each side of an inequality by a negative number. Long story short, this just tells you, hey, if you're going to multiply or divide both sides of an inequality by a negative number, we have to reverse the symbol. But again, feel free to pause the video here so that you can check out the rest of the slide. But like I just said, essentially, the rule is that we have to reverse the inequality symbol whenever we multiply or divide by a negative. So why do we have to do that? So I just have a quick little example as to, again, math is weird, right? There's all these different tricks and rules. This is one of those tricks, right? So we have to reverse the inequality symbol when we multiply or divide by negative because it's going to end up making it so that things get funky. So let's take a look at just a simple example, right? Here we have -2 is less than 4. That's a true statement, right? Negatives are always smaller than positives. So this inequality, as written, is true. But what happens if we go through and we multiply both sides by a negative? So if I write, we're going to do -2 times -1, 4 times -1, we end up with this statement here that 2 is less than -4. Well, we just said positives are always supposed to be bigger than negatives, and so this is not true. So it gets weird when we multiply by negatives, and it messes with our inequality. So this statement, again, is no longer true after we multiplied both sides by a -1. So we did keep things consistent, right? We did the same thing to both sides of the inequality, but those negatives throw it off. And so this is why we have to reverse the inequality symbol. So anytime you find yourself writing multiplying by a negative or dividing by a negative on both sides of that inequality, make sure you reverse that symbol, because then what's going to happen is, okay, well, instead of being a less than sign, let's reverse it to a greater than sign. And this now is true. 2 is greater than -4. So again, anytime that you multiply or divide by a negative, you find yourself right in that dash as you're saying, oh, yep, show my stuffs, multiply by negative, divide by negative, whatever. You have to reverse the inequality symbol. Otherwise, you don't end up with a statement that's true. So let's put that into action with some examples. On this one, we're going to solve and graph multiplication inequalities. And you're going to notice that in front of every single variable, there is a negative. -2, -4 1/10, -2 1/2, right? So for this first one, again, our steps to solve are very similar. We just have a little trick that we have to worry about at the end here, right? So -2x is less than 10. Well, to undo multiplying by -2, we're going to divide by -2. But this is where, again, if we find ourselves writing, ooh, I'm dividing by a negative, you need to reverse your symbol. So this is now going to say x is greater than -5. To check our solution, we just need to pick a value that's greater than -5. So let's say I pick -4, right? -4 is bigger than -5 since it's closer to 0. So -2 times -4 is going to end up being +8. +8 is less than 10, right? Now, let's say I forgot to reverse my symbol. So don't write this down, but let me just write it out to demonstrate what's going on here. Let's say I forgot. I'm going to put x is less than -5. I totally forgot the rule. Well, what's going to happen is when I go to check my solution, which is always a good thing to do, I would pick a value like -6, because -6 is less than -5. Well, if I put -6 in here, -2 times -6, that is 12. 12 is not less than 10. So if we don't reverse our symbol, this, again, is producing a false statement. So make sure that you remember to reverse your symbol whenever you multiply or divide by a negative value. So we checked our solution. We talked about why we need to reverse our symbol, and now all that's left is going to be to graph this. So we're going to put -5 in the middle. Hopefully at this point we're feeling like experts when it comes to graphing inequalities. We'll do -6 to the left, -4 to the right. This is going to end up being an open circle because it's a greater than sign. So we'll do an open circle, and then because again it's greater, you're going to go to the right. All right, let's try that again with this next one. That does involve decimals, but it's not too bad. So we got -4 1/10 multiplied by x is greater than 12 3/10. To solve this, we're going to undo the multiplication by dividing by -4 1/10. Again, because I'm dividing by a negative value, we want to make sure that we reverse that symbol. Positive divided by negative is going to leave us with a negative. And then this problem here, essentially, we're going to be moving our decimal point to the right one spot. This is going to be 123 divided by 41, which just ends up being 3. So we're going to get -3 for our solution. To graph this, we're just going to go through, again, make our number line. I could put -3 in the middle, -4 to the left, -2 to the right. This is going to be an open circle because this does not have the or equal to, so open circle. And then it's less than, x is less than -3, and so it's going to go to the left. All right, and then we have our last one here, -2.5y is greater than or equal to -8. So we're going to go through and use division to undo that multiplication that's happening to our variable. We're going to make sure we do that on both sides. So this -2.5 divided by -2.5 cancels out. We're left with y, but because I divided by a negative, I have to reverse my symbols. Now it's going to be less than or equal to, and then we're going to do 8 divided by 2.5. So this is essentially, if we show our work off to the side here, it's going to be the same as doing like 80 divided by 25. This is going to end up being a positive answer because we're doing a negative divided by a negative. And then we just go through and set this up as, again, long division. So 25 goes into 80. That's going to be 3 times because that's 75. And then we'll have a 5 there. We can add our decimal point now. Add our 0 and bring that down, and then 25 goes into 50 2 times. So this ends up being 3 2/10, and again, it's going to be a positive. So y is less than or equal to 3 2/10. And then to graph this, we'll just make our number line here. We'll put 3 2/10 in the middle, and then we can do 3 3/10 to the right, and then 3 1/10 to the left. This now is going to include a closed circle because of that or equal to. So we're going to have a closed circle. And then because it's less than, that means it's going to the left. So those are some multiplication inequalities. Now let's take a look at the opposite when we have division inequalities. These are all going to be the same idea though. Each one of these, you can see we have dividing by a negative, dividing by a negative, dividing by a negative, which means we're going to end up having to reverse our symbol. Otherwise, what we're going to get is not going to be the correct solution. So make sure you remember that trick when you work with negative coefficients. So starting with the top problem, x divided by -4 is greater than or equal to 3. Well, to start this, to undo dividing by -4, we're going to multiply by -4 on both sides of our inequality. Again, since we're multiplying by a negative, we need to reverse that symbol. So notice that I'm writing it as a less than or equal to sign. And then 3 times -4 is going to be -12. So we get x is less than or equal to -12. To check our solution, I'm going to pick -16 because we're going to have to divide by a multiple of 4, right? So if I use -16, because -16 is less than or equal to -12, -16 divided by -4 would be a +4, and 4 is greater than or equal to 3. So that is going to end up being perfectly fine. So to graph this, we're just going to make our number line, put -12 in the middle. We can do -13 to the left. We could do -11 to the right. This is going to be a closed circle because, again, it has that or equal to. And then my arrow is going to the left. Okay, so let's try it with the next one. So we're going to solve x divided by -2 25/100. That is less than or equal to -4. So to undo this division, we're going to multiply both sides by this -2 25/100. So I'm going to write over the problem here so you can actually see some of the work. So -2 and 2500ths, that's what I have written here. It's really hard to see because I used gray and that was a poor choice, but we're going with it. So what's going to happen is we're going to have x, and then it's going to be greater than or equal to, because I am multiplying both sides by a negative, you have to reverse the symbol. And then we're going to have this 2 and 2500ths times 4. So think of it as just 225 times 4, and that ends up being 900, which then we have to add our 2 decimal places back in. So -4 times -2 and 2500ths is going to end up being a +9. And then we just have to graph it. So graphing our solution, we'll put 9 in the middle. You can go 10 to the right, 8 to the left. This is going to end up being a closed circle, and x is greater than, and so it's going to go to the right. All right, last example for this video. And then for my students, make sure you watch to the end because I have some hints and tricks to help you out with your homework for this lesson. So back to our last example here. A divided by -1 and 2/10 is greater than -4. So if we're dividing by -1 and 2/10, that means to solve this, we're going to multiply both sides by -1 and 2/10. So that cancels out, right? Division and multiplication are inverse operations. Because I am multiplying by a negative, I have to reverse my symbol. That is going to become a less than sign. And then this here is just, think of it as 4 times 12. So that's going to be 48, but add your 1 decimal place back in. So 4 and 8/10, and it is a positive because you do have a negative times a negative. And then the only thing left with this problem is to graph it. So we'll have the 4 and 8/10 in the middle, and then I'm going to put 5 to the right, 4 and 6/10 to the left. Remember, you can count by any interval that you want as long as you make sure it's consistent. This is going to now be a open circle. So it's the only one on this screen that was an open circle, and then it's less than, which means it's going to the left. So that's it for the examples, but for my students in your homework, right? When you get to number 12, make sure you round your answer. It does not turn out to be nice. I also have it written here exactly what you need to solve in order to complete the question. So make sure you are writing this down for number 12. And then going back to number 11, I have these hints here. So you're going to set up the inequality for the points lost per banana. They're talking about a video game, right? So set up the inequality for the points lost per banana, and then you're going to multiply your answer by the time to get the final solution for number 11, okay? So just something to keep in mind as you work through your practice, which again is written here for you, but number 12, round your answer, there's the inequality you need, and then number 11, set up your inequality for the points lost per banana, and then multiply that answer by the time at the end so that you can get your final solution. All right, and that's it for this video. Thanks for watching.